YT channel and simultaneous FB live streaming. Okay, we're now going to another topic. It's gonna be the heat change. The heat change of the enthalpy change of the reaction and also Hess Law, the constant heat of summation. Ganon. Okay, so our problem here is gonna be like, wait, chart. Like this. We start with ano lang siya, sayon or easy round. Then average round and after the round chart. So we have 2 moles of graphite, okay, plus oxygen gas is equals to 2 moles of carbon monoxide, like that. So this is your overall reaction, Rx. Okay, and then your first reaction here is C, okay, C graphite. Graphite, guys, is a carbon, huh? Carbon. Graphite plus oxygen gas is equals to carbon dioxide. Okay? And then we have delta heat of formation of the reaction. Okay, delta H is equal to negative 393.5 kilojoules. Okay, take note, it's kilojoules. There's no unit in the denominator and there's also no kilojoules per mole, kilojoules per gram. Take note, it's very clear. So no unit in that. So no need to cancel chupa in the comment like that, blah blah blah. So and so. Okay. This is equation 1. Okay. Equation 2. 2 moles of carbon dioxide, okay, will be equal to 2 moles of carbon monoxide plus oxygen gas. So our delta H is, so guys, negative 566. Oh, negative 566. Okay, 566 0. So much, guys. 01 kilojoules. So calculate the enthalpy change of reaction. So meaning to say, we are asked for the delta H Rxn. Enthalpy change of the reaction. Reaction is Rxn. Okay, question mark. Ganon. Mukhaon sa kumpan, kay gutom ko. Char. May ganon. Yes. Yaw-yaw. Uy, mga akong ninyo. May mga akong tagpan. Hindi ba? Kaso tayo, taas pa rin guys. Nagutom ko hinaw-yaw. Diba? Sige, sinasama banga. Alam ang politika niya. Maglaris ka ng politika. Magbunot ta. Narinig ka sa... Ganon. Okay? Init yung coffee, guys. Uy, I love it. Wow, bongga. Diba? Okay, going back to business. And what's this business all about? Chart. Okay, now the Hess Law states that it is a constant summation of the heat, of course, like that. And then it is the enthalpy change for the reaction equal to the sum of the heat changes. That is Hess Law, something like that. Okay. Then, heat changes from equation 1 and equation 2. So we need to say, we need to add this negative 393.5 kilojoules and negative 566.01 kilojoules, but we need to take a look first the chemical reaction so that we can come up with this overall reaction, which is 2 moles of carbon graphite plus oxygen gas equals to 2 moles of carbon dioxide. Now I will put here the total overall reaction. 2 carbon graphite, okay, like that, plus oxygen gas is equals to 2 moles of carbon dioxide. This is the overall chemical reaction. And this is what we need for the delta HRXM. Okay, by using the individual delta H of the equation 1, equation 2, equation 3, you have to add them all. Okay, like that. But before going to this overall reaction, if we add this 1 and 2, okay, not all the time we can get this overall reaction. That's why we need to adjust this equation and equation 2 so that when we can add the 2 equations 1 and 2 will yield an overall chemical reaction such like this. But because if you add this sometimes, it will never have an appearance like this. So that's wrong. Then we need to manipulate. So what are the manipulations in Hess Law? First, this is techniques. Technique number 1. If you try to reverse equation 1 or equation 2, whether exothermic or endothermic, something like that, then you need to change the sign of your delta H. Okay? For example, if this will become CO2 is equal to carbon graphite plus oxygen gas, you reverse the equation, then this will become positive 393.5. That is the first rule. The second rule in Hess Law of constantheatofsummation summation, if you multiply the delta H with the number of moles, okay, that is because you have number of moles and coefficient in the reaction. So multiply that also with that, how many moles. For example, if you divide this equation number 2, everything, CO2, carbon monoxide, just with 2, okay, all, then multiply also your delta H with 2. So meaning to say, your delta H is always dependent with your number of moles. You get the point? Yung tapon mga palangga, okay, because the enthalpy change is always directly proportional to the total heat content or the heat content. And the heat content always involve the number of moles in the stoichiometric relationship of the different chemical equations involved. So normally, you will do that. That's the reason. Okay? Like that. It's always the number of moles, our basis for the stoichiometric relation. There's no other. Okay? Like that. That is the second point. Now we start now. We're applying those rules. Okay? Now we have this product to submit. Ayun na kung ano mga charot. Okay? Mayroon siya pang overall reaction mga palangga, no? Okay. Tapos tani siya. Tapos kani. Okay. Now, take a look. If this reactant carbon and oxygen gas, if you add that to it, will appear here or not? So, add all the reactant, it will become carbon graphite plus oxygen gas plus CO. It will the same yield like this? Or not? If it will yield the same like this, then you don't have to change or to exchange the reaction or reverse the reaction. Something like that. Okay, you get the point? Okay, now take note, your product is carbon monoxide. Here, carbon monoxide is your product here. Okay. It's in here. Carbon monoxide. Okay. And then your reactant is in the oxygen gas is in the reactant. And the CO2 is in reactant. If you try to add this, let's say lang for the purpose of discussion to prove that it's incorrect. Okay? Like this. We will say graphite. Okay. We will also introduce the error because so that we can justify that is gonna be the case. Not only showing directly to the correct one, right? So oxygen gas plus 2CO2. So the technique is add all the reactants, the later add all the products. So CO2 plus 2 moles of carbon monoxide plus oxygen gas. Take note what will happen for the total. Okay, you get the point. So though we can cancel the oxygen gas, okay, like that. Cancel the oxygen gas because it has the same mole, left and right. Okay. So no other cancelable? No, there's no other cancelable, right? So take note. So if you try to transpose this CO2 to the left, because it has the same quantity. In mathematics, the same quantity group together, the same variable group together, something like that. Okay, so for example, x, group all the x's, the y's, like before subtracting, before multiplying. It's just like that also here. Okay, so we have C graphite, okay, plus CO2 minus 2 moles of CO2 minus 1 mole of CO2 in the right, CO2. Okay, equal to 2 moles of carbon plus 2 moles of carbon lang siya because the oxygen gas will be cancelled. Okay. So this is the final reaction if you add the two directly. C graphite plus carbon dioxide plus 2CO. The same ba sa overall reaction na na-produce natin na reaction? Or not? So dili. Because we have .CO2 in our overall reaction. You get the point? So this is not correct. We cannot add directly. Okay? I'm pointing out, we cannot add directly without reversing any of the equations first. Okay? Because that is the first step really, is to add directly if it is possible. Okay? Like that. So we cannot add directly because the overall reaction will not satisfy. Okay? Now, how about reversing first the first reaction? Let's say this one. It becomes now CO2 equals to C graphite. Okay, mga palangga. Plus oxygen gas. Gi-reverse na ko. Then, this will become positive 3.5 kilojoules na. Okay, let's say. Then add this equation 2. It will yield this overall reaction here. So, 2. Meaning to say, you're only changing, reversing the equation 1. Pa. Not the 2. Okay, so, CO2, gano'n na aayarin nyo siya. Okay, 2CO2, gano'n. 2CO plus oxygen gas. Add the 2. Ganun. So it will become 2CO3 is equals to C graphite. Okay. C graphite plus 2 moles of oxygen gas plus 2 moles of CO2. CO. So take a look if it is correct or not. So it is not also correct. So you will not reverse the equation. How about reversing the equation 2? So go back again to negative 393 because you did not, it's not allowed. Okay. So reverse the equation 2. Okay, let's say ano na siya, ano siya. So it's gonna be 2 moles of CO plus oxygen gas is equal to 2 CO2. Then change this to positive. Okay? Now, add the equation 1. So C graphite, okay, plus oxygen gas and CO2. Okay, ganun mga palangga, di ba? Okay, ano naman siya, mga nagibali. Okay, so 2CO plus oxygen gas, 2CO2. And then, i-add mo sa usaw, mga nagibali, so C graphite plus oxygen gas, CO2. Now, add the two. So, 2CO plus C graphite, okay, plus 2 moles of oxygen gas, 2 moles of CO2, or 3 moles of CO2. 3 moles of CO2. It is correct in overall reaction. We will get like this. No, it's not the same. Okay, so it's also wrong. You get the point? Okay. Ano siya mga palangga? Okay. So, it's also wrong. So, erase this one. Okay. So, the last option really, if we cannot do, if we reverse, take a look that this CO is already in the product. Okay, in the product. So this will be correct already. Okay, now C and O is in the reactant. This is correct already. So actually, you need to add back to manipulate the number of moles. Right? Because we do already the reversing, chuba chuchu and everything and we add, we don't yield the correct overall general chemical reaction, which is this 2 carbon graphite plus O2. And now we have to take another analysis in which we need to look the product and then we adjust that before adding. For example, we have C graphite plus oxygen gas plus 2 moles of CO. Then, be sure that when you add that CO also will be in the product. And the same thing, oxygen gas also on graphite will be in the reactant. So normally, you will never reverse, but to add. Then, this is the time you will multiply something. 2 cancels any of the elements and compounds involved in your chemical reactions. Because we cannot do anything. Because second step naman gini siya ang multiplying by number of moles. Priority man ang reversing. Like, priority ang i-add direction. Priority, first add all, and if there's problem, reverse any one of the equations to satisfy the general chemical reaction. 3, last choice is to multiply with a certain number of moles to cancels the same quantities. So we go on the rule number 3. Okay, so now we have CO2 in the product, and we have also CO2 in the reactant. We have CO2 in the product in equation 1, and we have CO2 product in CO2 in the reactant. Now, what you will multiply to cancel the CO2 here? You will multiply a certain number of moles or coefficient to a compound or element that is lesser or insufficient number of moles. So in equation 1 and equation 2, which is insufficient or lack of number of moles, it is equation 1 or equation 2? Obviously, equation 1 because it is only 1 mole of CO2 and 2 mole of CO2 in equation 2. So this is the time we will multiply the equation 1 with 2. Ganon. So we write downside here. 2 carbon graphite, okay, plus oxygen gas is equals to 2 moles of oxygen gas, plus 2 moles of carbon dioxide. Upon multiplying this by 2, the whole thing. Right, so T2C graphite plus 2 moles of CO2. Now, your delta H here starting with negative, okay, you should also multiply that with 2 because you multiply the equation with 2. So this is negative 393.5 kilojoules times 2. O ganon. So pinanamalay mo enthalpy change. Okay, it's gonna be 393.5 times 2. So it's gonna be 787, right? Okay, 787 kilojoules, mga palangga. Now, this 787 kilojoules, that will be added later. Okay, but wait for a while. Okay, now we have now this one, 2 moles of carbon graphite plus 2 moles of oxygen gas plus 2 moles of carbon dioxide. Add the second equation. 2 CO2 is equal to 2 moles of carbon monoxide plus oxygen gas. Add the 2 if we could yield this overall reaction. Okay. 2 carbon graphite. Okay. Okay, plus 2 moles of oxygen gas plus 2 moles of carbon dioxide. Okay, mga palangga. Okay, plus 2CO2, di ba? Kaya product mo na siya. And plus 2 moles of carbon monoxide plus 1 mole of oxygen gas. Ganon. Okay? 2CO2, 2CO plus oxygen gas. Okay, ganon. 2 graphite, 2 moles, 2CO2. This is 2CO2. Review properly because it will be wrong if you not review. Okay, and then 2CO2, 2CO plus oxygen. Okay. Now let's take a look if there will be cancelled to simplify your chemical reaction to equal the overall reaction given in the problem. So we have 2 CO2 is cancelled because left from right. Cancel. What will happen to your oxygen gas or carbon monoxide? It will be cancelled or not? No, it will not be cancelled. Okay? Now, in this equation, we have 2 moles of graphite plus 2 moles of oxygen gas is equals to 2 moles of carbon monoxide plus oxygen gas. Now here, 1 mole of oxygen gas in a reactant. Since if you try to subtract 2 moles of oxygen gas in a reactant to 1 mole of oxygen gas in the product, it will become oxygen gas. So let's rewrite that one. 2 carbon graphite plus oxygen gas, 1 mole of oxygen gas after subtracting it from 2 moles to 1 moles here, then equal to 2 moles of carbon monoxide. Take a look and compare your answer if it has the same equation here in your overall reaction. Visual, 2 carbon graphite, the same, 1 mole of oxygen gas, the same, and 2 moles of CO, the same. Now, this is the time to add. Okay? And we don't change this one because we don't reverse the second equation. We don't times this to something, any number, because we don't multiply. Right? So add that to. Okay? Add that to delta H. Your delta H of reaction is equal to 787 kilojoules right after you manipulate the multiplying the 2 moles plus negative 566.01 kilojoules. So this will be your delta head of reaction. Enthalpy change of reaction. Okay. Hat talaga. 787, okay, minus 566.01. So your enthalpy change of the reaction is 220. Be careful also with the grammar, huh? Change, because there are 2 quantities involved. You'll never say change if only one is involved. Grammar, English grammar. Okay, so you will say enthalpy change of reaction because you are subtracting the 2. There are 2 quantities involved. But if there is only one, you will never say change. Be careful also your grammar for this. Okay, enthalpy change of reaction. Okay, like that. So that is 220.99. If you don't want to use the word change to make it safe with the grammar thing, use only delta H of reaction. That would mean the same thing. Or delta heat of reaction. You get the point? But if you carry the term enthalpy, you need to put the word change. Enthalpy change of the reaction. Okay? So be careful also by putting the statements come out in your mouth. Something like that. Okay? So the answer will be the enthalpy change of reaction is positive 220.99 kilojoules, meaning this is an endothermic process. Meaning the heat energy is being absorbed by the system or being added by the system coming from the surrounding. Meaning to say, the surrounding is releasing the heat energy to the system. Okay? That's it. Any questions so far? Mga palangga, before going to another example. Kaloka. Diba? Uy, mga palangga. Meron pa mga questions? Any questions so far? Sa sa mga science lovers. Okay, nothing else. Thank you so much for watching this vlog, second segment, right? And then you can comment, you can share anything you want, and then you can subscribe to my channel if you like also. So you have the full freedom to do it or not. It will be fine. And then you can also click the notification bell for some news updates of I Am a Singer, channel first. Bye bye, God bless everybody. Happy Saturday. Kaloka.